we go back again to the platform which we're going to do the star of the show is launching the G-meter. So the G-meter, again, I said, is the hardware portion that's measuring multiple circuits. I use this, again, we use this primarily, and me personally use it for my customers. I have residential and commercial customers. You can actually log in and you can see multiple buildings. If you were a building owner, for instance, you could look at different buildings. I look at different accounts. Primarily, what I where my most of my businesses come is from working with schools, and right now in California, I'm working with about 5 or 6 different schools, one of which has been very progressive in installing our technology. We can look at different buildings on the campus. We have 4 different buildings that we're monitoring on the campus in this aspect. Again, I told you we also have some homes. So if I actually look at specific addresses, we can get into show you what's actually happening in a home. That's not. Let's go to this one here. So this is a home that's basically in my area here. I'm in Los Angeles area. It basically, what happens is that you have a dashboard, and this is, again, this is the residential platform that you're seeing. This and they don't differ necessarily too much, but typically when you come into your dashboard, you're seeing how you're, typically tells you how you're doing. You actually can punch in your history of energy bills and your utility rate, and now it's going to give you an indication of what your projected bill might be for the month. It tells you how you're doing so far, and this would be for this current period. It gives you energy trends. It tells you the peak time of day, typically in that half hour. It breaks it down into percentages of how, if you use it during the day or the night. You can set these time parameters to however what you would consider your daylight and night times. Gives you your averages based on, again, with the utility rates that we enter in. Then it also tells you how you're doing today, in the last 7 days, 30 days, gives you your updated weather report, and then actually gives you how you're doing in a pie chart or a bar graph in terms of what's using energy in your home. And in this particular one, in this particular home, we've got from their main panel that we're in, we're measuring different sub-panels. So you can see that whatever's on their downstairs sub-panel at this point is what is using the most energy in their home, followed almost by their pool sub-panel. This other display is when we go in and we hook up our meter to the electrical panel. The first circuit that we always monitor is the main power coming into the building or into the home. Typically what you as a utility would be measuring. We hook up with the current transformers to the main line, and then all these the other circuits that we're measuring on the G-meter hardware. We can measure it's 5 other circuits, so I can measure up to 6 circuits on the residential G-meter. And basically, now that we've measured the mains and the other 5 circuits that we've actually specifically marked out here, now we can actually group the other ones that we have not hooked up to current transformers to actually group those other circuits and maintain those now into a measurement. So now we've actually measured everything in the electrical panel so that we can have an understanding of what's actually using energy in the building. And the way that we monitor, we'll take you to the live feed, is that we like to say basically we do things in live real time. A lot of people say they do things in real time, which come down to hour segments or 15-minute segments, some 5 minutes, but we're doing multiple circuits every 5 seconds. And as you can see over here on the right side where I'm circling with the arrow over here on the right side, you can see the movement that's going on and see that this is what we're tracking. So it's really what I like to tell people, it's kind of like watching a stock ticker. You can literally see what's using money in your home, using electricity and costing you every second of every day. As you can see over here on the right side, what tells you what we're measuring. So there's our main panel, which is giving you the current read of how many watts the entire house is pulling. Those are the sub panels underneath, what they're using, and then the other things that we're measuring in their house. So as you can see, things come on, come off, things spike up, spike down. It has an overall effect on their KW that we're measuring in live real time. Are there any questions so far?
Brent, I was going to just ask if you could show a commercial application as well, and how it would operate in a campus-like setting. Either a business with multiple buildings or a school, as you mentioned earlier, or is it just, I mean, it's obviously the same, but I just wondered how it's broken out by building then.
And no, that's great. That's a great segue because I was going there next. So.
Oh, okay. Sorry.
That's great. Are there any other questions before we move on?
Yeah, I just had one. Is this system limited to 6 sets of CTs? Is that what you said?
So that would be per G meter. You would be limited on that, and that is on the residential application. You can actually put in multiple. So if we wanted to measure every single circuit in this home, we could. But obviously, depending if it was, of course, if it was 18 circuits, we'd need three G meters. On the residential side, on the commercial side, we can measure up to 8 3-phase circuits at a time and with multiple boxes. And then I can go over to the commercial one and I can tell you how we set that one up. Which is
real quick though, on the way you have it set up here, you're measuring 6 circuits, and then you're kind of just doing math and figuring out the circuits that aren't measured. So if you had a circuit like you actually had there that's using very little energy, how easy or hard is it then to just say, I don't want to measure that circuit anymore. I want to get something out of that other, because the other is using a lot of energy, and I don't know what all that other is. So just moving CTs around, does that take an electrician to do, or a homeowner can do, or how easy or hard is that?
So every transformer. So you do need an electrician, a licensed electrician, to install this. Typically, the CTs are clip-on, or with the smaller CTs, what it is, like you mentioned, a smaller circuit, you would have to basically remove the wire out of the circuit and then slip it, slip the other CT on. It's not that difficult, but yes, we do recommend that, the consumer doesn't do it. We want an electrician in the electrical panel for safety reasons.
Okay, thanks.
You're welcome. So I'll go to the school that I work with. You mentioned, how it would look. So typically, if I go back real quickly to the dashboard. This is the school that I'm working with. You've got, like I said, we've got 4 buildings, 8 classrooms with 1 utility room or 1 storage room, and their restrooms. We basically started out with just 1 building as a pilot, which was this building number 6. And as you can see up here in the left-hand corner, these are the different things that we can monitor. So we can jump around for different buildings that are on the campus. So if we wanted to go look at building 6, we just simply click on building 6, and then it would take us over to the dashboard for building number 6 and give us the readout there. And we can obviously jump around to the different buildings and see what's going on in that building right now. If we go again to the live feed, this is the live feed that's happening right now as we're demonstrating this. And what we're monitoring, I told in these 9 rooms and the restrooms are their lights and HVAC. So we hooked up to the sub panel there, and we've got 2 G meters, 2 boxes hooked up to be able to measure all of these. As you can see, the way their lights were, they did not have individual circuits for their lights. So they have, in case on one of these, they have 4 rooms on one circuit, and then their restrooms also were connected with 2 rooms. So it really, whatever's on that circuit, we can measure it. And obviously, if there were individual light circuits, we could have measured them that way as well. But typically, to capture all of their HVAC and the lighting in these 4 buildings, we used 2 hardware devices to get at these. And again, it's 3-phase power, so we're measuring 3-phase every 5 seconds. If you want to get into specific circuits to measure, you can actually deselect. So we could actually deselect the little checkbox of the mains, and if we just wanted to look at just air conditioning, we could look at just the air conditioning. So we can actually really get in and look at individual air conditioners. We could also just even look at an individual air conditioner if we wanted to, of what's running, and an individual light circuit if we wanted to. But there you can see there's the room 604 if we just wanted to look at it, and you can see that room 604, it just came on about just before 11:20 a.m. In California time. We can actually go back in time. So again, once, as I said, as we're measuring this every 5 seconds, we're storing that data. We have the ability to go back and look at the live feed for 48 hours. So for instance, we can go back to 5 p.m. On November 10th, which would have been the day before last, so we could actually look at what's happening at what was happening at that time. We could simply come up here as well if we wanted to click up to 6 p.m., 7 p.m., so on and so forth. We can click away to each hour within that 48-hour period to see what's going, and you can see from 10 o'clock to 11 o'clock what was going on. If we went back to, you can actually scroll down here and then look at any of the actual hours previously, and we'll go back to 6 o'clock this morning so that we could actually see what was going on during startup. So we'll actually go back to 5 a.m. So at 4 a.m. you can see there were actually some lights on, which was unfortunate. But now you have actually 5 a.m. somebody came in, turned the restroom lights on, certain lights came on. You can see the spikes associated with things turning on and turning off in that time. Go to 8 a.m., which is pretty much when school starts to come in session. Now you can see all of the air conditioners and things kicking on and causing the KW spikes during the start their day. We have, in addition to this graph, we can actually click on this text button, and then the text button will actually break down what each of the individual circuits are doing, giving you what each used within again that hour time period, what the minimum watts were, maximum watts, kWh, kVA, and then actually what was spent. So again, we put in the utility rate, and the utility rate is calculating out what each of these circuits are using. I told you we did have the data in these live feeds for 48 hours, but your overall historical from whenever we plug in the G meter, it starts from day one in the first hour, what have you, of every when we first plugged in. So we actually have a historical just by quickly going up to monitoring and then clicking on historical. We can then look at the historical graphs, and again we can go to any building we want and look at the historical information on each of the buildings just by simply clicking up there in the top bars. What we're looking at right now is just what's been happening today so far. So already we're recording the historical data. So there you can see starting from midnight on building 5, what was happening. If we actually scroll over one of the bars, it gives us what that color code is, along with over here on the right what these are as well. So you can see at 8 o'clock you've got the blue, in this case, indicating the other circuits that were running, as well as overnight. And then at 7 o'clock, for instance, you can see which lights started to turn on and started to run. We can actually break this down. We could actually go back, if we wanted to go back to the month of October and click on a certain date, and we just wanted to look on October 1, we could go back into that day. And now we're looking at what happened over the entire period for that day, and what was using energy in those specific hours. If we go back again and we click on the text button, now we've actually broken down what was being used for the day. If we wanted to click and look at what was happening for the week or the month or the year, we can also do that as well. So it breaks it down, all of your data into however you want to look at it. So it's not necessarily, it's basically doing all the automation in terms of downloading the data and giving you something very useful to help you look at. And if you look at the other, so when we get into the historical portion of here, the historical graphs or the historical read, and we're clicking on the text, again, we're looking at things like total energy, average energy of the individual circuits, average power. But one of the most powerful things that has been helpful to me, especially because this school is in a desert area and they use a lot of air conditioning, that we can go and look at the actual running times of the lights and the air conditioning. So because we're measuring live, we can now have our data spit out when things were running, when they're not, and calculating the actual running times. And again, calculating again by the day, the week, the month, the year, how much things are costing in those time periods. As well as you're getting your temperature readouts of what your minimum temperature was for the week, the maximum time, or for the month, or for the year. You go back and it can break down the graph data for you, again, by the week, by the month, or by the year. And so now we're looking at a month period going back to October 12th. We could even, if we wanted to look at the entire month of October, we could just click on October 1, and again, click over and see what was using energy in those buildings on those specific days. If we really wanted to see what was happening on a specific day, we just actually click on that bar graph now, and it takes us straight to that day, so we can go back and look at the day as to what happened and try to reason what happened within that day. Just to let you know, like just going back on some of these with this school, there's a good example as to one of the things that helped me get the job, if you will, and using the data. We basically put this in for started working with this school, when we were just first starting out and looking for ways to prove that the technology worked. So we did a pilot with the school, and they allowed us just to put it in on building 6, and we just monitored strictly for a year. We typically, that's all we did, was just do the monitoring. And then when I went back in, I went back to and this was probably 2 years ago, but we actually went in and I met with the superintendent of the school, 2011, July 4th, 2011, and I showed her basically that she had all of these things running on the 4th of July, which is in the middle of the summer on a holiday when you pretty much knew that there was going to be nobody at the school. And when I clicked on the text, I showed her that the restroom lights had been on for 24 hours. And as I clicked through this and went from day to day, I showed her again that they were on for 20 hours. Basically, I showed her that these lights had remained on for a full year without ever being turned off. So, you know, that was the power and the data, running times, and things like that. And before we move on to the next portion, we do have the ability now. You wanted to look at what they did on July 4th a year later in comparison. You know, we can do comparative dates, we can do comparative weeks, we can do comparative months. So now we can, you know, in a way we've set a benchmark by recording the data, and now we can come back to see how they're doing and improved. So this was actually, we did put controls in the building, which is the next part that I'm gonna get to, and you can see how we went from 2013 on up to this year on energy use in that building, and how dramatic the savings was. On this building in particular, once we started controlling things, we got a 50% reduction in energy on the. But it really shocked me because I was only estimating that we'd only get about a third. But just by turning things off and making them aware of what was going on, we huge because they were wasting so much. So that, you know, leads us into what I said is where we actually do have controls. So we actually are now controlling all 4 of those buildings, and we can actually look in at each building on the control. So if we wanted to look at building 6 and what we were controlling in those buildings, we actually installed basically what we like to call the GreenNet Energy Management System, or G-meter system. It's a plug-and-play system. So all we did in these restrooms and classrooms was replace the existing thermostats with communicative thermostats, which were Wi-Fi, and then also lighting switches. So the lighting switches were also communicative. They are Wi-Fi as well as power line, so they get a dual band signal. And we used Insteon product in these classrooms. If you've ever heard of Insteon or Smart Home, that's what we used in this. It's worked quite well. There have been a few issues with drops, but for the most part, we used it and it's worked well without a lot of drops, as long as we've installed different access points around each classroom. So typically, what we did is we installed the communicative thermostat and the light switches, and we actually had an outlet that we installed, which was the outlet closest to the thermostat, so that we could get a very, very good signal to that thermostat, because the outlets and the switches are, like I said, dual band, and the thermostats were Wi-Fi. So we've actually had a pretty good success by building you know, the mesh network within these. Within the restrooms, we actually have a relay. Go ahead.
Oh, sorry. I thought it was on mute.
This is Joe. I had a question for you. Is this fee for service? So is this a service you guys provide, or is this something you set up and the end user can actually do all this controlling?
So the end user. So again, we're a consumer-facing platform. So, you know, we're all about the end user having control. So
okay.
in the case of
contract with these folks, where you control their loads or anything like that?
I have to have permission to do that.
Yeah.
And
okay.
And I am so you know my business model. We are general contractors. We started, like I said, we're general contractors. So we did do the installation of this system in the school. However, what happened is we started getting the data and being able to control things. You know, we basically train the building owner, we train the homeowner on how to use it. And again, it's very sort of it's easy to understand and use. So in other words, when we put in the controls, they will pull up this platform. It will show all of these buttons. It will show all this. They don't have to program any of this. This comes in. However, where we are consultants, and we do offer consulting services to our clients, and in particular this school, I am a consultant with them, so I do have control on turning things on and turning off, and I get actually notification, which will be the last part of the demonstration I'll show you, but I do get notification every night from the school when things turn on. So the green lights that the green areas that you see over here, that means that that light is on. The thermostat being blue means that air conditioner is actually running. If we wanted to, which we won't turn the lights off on the kids in the classroom today. They are in class today, but we do have that ability to turn things on and off, as well as the thermostats. And you can actually click on each individual classroom has been or is currently. And in this room in particular, you can see right now the teacher has that set at 74 degrees. This school, again, because we're consumer, we allow them. We make as their consultant, I make different recommendations to them to save energy. But at the end of the day, again, it's their call. So in this instance, they do give the teachers free rein to set the thermostats. Any of these things have a manual override. So if I turn the lights off on them and there was somebody in the room, all they need to do is go over to the switch and turn it back on. Or if I set the thermostat down, they can go over and manually turn the thermostat back up. But we did put in a check, if you will. We try to install checks and balances. So we have a very, very easy way to program these thermostats. So in this instance, we had 36 thermostats in them. I literally programmed all 36 of those thermostats in less than 15 minutes. Basically just by coming into our easy programming device, which is create a program, which we called 85 degrees at 5 p.m. I typed in the time, 5 p.m., and what temperature I wanted those thermostats to set at that time, and then we saved that program. If we wanted to actually do a startup program, which we are experimenting with right now with doing start times in the morning to cool down the classrooms at an early hour when the temperature outside is most coolest, and it sort of cuts down their round times. We can we could add a startup program. We could add a new program and say at a certain time go to a certain temperature or start up at a certain time as well. And we can also eliminate them. So if we wanted to eliminate, we can basically stack programs on here and create multiple programs on an individual thermostat. We do also have capabilities for things such as automated demand response. We are set up. I particularly actually am new kid on the block for Southern California Edison. My company is an aggregator for their capacity bidding program, but we do have the ability to do auto demand response in whatever building we're set up in. If I simply wanted to do a shutdown on this building right now, we would actually come over to scenes, which basically we've created a scene for all of the buildings, and basically it groups all of those outlets and things into one sort of folder, if you will, and if I wanted to, I could turn all of those lights off with one click. And then obviously we have the auto demand response set up here that we can build in or talk to the utilities system. However, that would be automated. Obviously, if the utility wants to send a signal, we would open up our platform to be able to receive the signal and then put our folders, if you will, our scenes, our strategy, our demand response strategy into place and run that strategy. I do get, I mentioned I do get notifications, so we can actually go into the notifications, and every night I get a text message from the school on these different buildings that when things are running when they shouldn't be, that I get a text message or an email. We can set up an energy usage thing whereby if a certain air conditioner, we want to put in the parameter that it exceeds or does not exceed a certain kWh within a certain period, which could be 15 minutes, 5 minutes, an hour, a day. If it exceeds or does not exceed that specification that we've built in, we get an email or a text message by the same way, and we can save that, obviously, and we can also set upper thresholds or lower thresholds. So if a certain circuit we wanted to set up reports more kW for a certain amount of period of time between certain hours of the day, we can actually say, if it exceeds that certain parameter, also send us an email or a text message. So in this school, I get text messages at night because I showed you we had programmed all of those thermostats to go up to 85 degrees at 5 p.m. So anytime a teacher or somebody or a custodian comes into the room after that and turns that air conditioner on, I've got a very low parameter in my upper threshold that we get notified that that air conditioner has come on, and then we can actually go back to our control panel either online or in the case of myself and the maintenance facility guy at this school, he has an iPad and I have my phone. We do on our app, and then we're able to turn that light off or that thermostat down from our apps, from our mobile devices.
Yeah, looks like in the school scenario, your system's paying for itself.
Oh yeah, we definitely.
It's over, yeah.
Yeah, I mean, we saw the payback, as I told you, because it was such a lot of waste going on. This paid off within a year. The monitoring service, it paid off within a year. We got them to where their overall bill was knocked off about $1,000 a month just by starting to control these things in these buildings. What was the other beautiful part about this is, we're looking at the monitoring and the control, but now, whereas a consultant, which has also kind of blossomed here in the state of California for me with schools, is we have a thing, I don't know if you've heard about it, but it's called Prop 39. And basically it's tax dollars that are going to schools for energy efficiency projects. And so in the case of this school, I have a great example, which is that we basically controlled things, got things under control to some degree, or to a good degree, and I know that we can improve upon that. But the thing that happened is that we saw, the school saw the results. So again, we're changing behavior whereby they can see this, they can understand it. The teachers now understand, they're a little bit under watch. We know 58 degrees during the day. And the next step to this is to bring them in and educate them in, so which is what we're going to do, to just sort of control, and the students also, because the students love this stuff. I mean, I've shown all this technology to kids. They're obviously into it, and they want to make a change, obviously, in their school. So that's the next step, to educate them on that. But the thing that, with energy efficiency and the savings are, it was like, what can we do next? So now at this school, we have actually done retrofits. We've actually retrofitted this school with a lot of LED lighting, one of which was their parking lot, which as I'm talking, I'll click on that, and we can go, and basically before we did their parking lots, which were like high pressure sodium, they basically had these 300 watt high pressure sodiums, and we went to 50 watt LEDs. And I'll just pull up I think it's the date here. It would be 2011. Oh wait, November. Bear with me. Oh, we want to look at the month. November 2012. Let me get the year right. Zeroing in. Sorry guys, it's a few. There we go. So this was, as you can see, we just put in, so we can actually put a meter on as well on $1,000 if we just wanted to do them. So that's kind of what we did on this before we did the retrofit, is that we did the before, which you're seeing here, which were the parking lots before. Retrofitting these 3 days, you can see the energy use going down, and then once we installed the LEDs, the difference on what they were using each day, which you could again go into each day. You can see when the lights were actually running, when they come on, and then look at that data in terms of cost, hour, running times, things like that. So we're actually measuring again at the circuitry level. So we basically say that we can benchmark that circuit. We can prove any energy efficiency measure because we're doing it at the source that's being affected by that energy efficient measure. That's about it that I have for today. I mean, the other thing that you can see, this one last thing I could show you is monitor setting. We can, again, it's because it's consumer. The consumer sets up all of their channels, their names. Of course, we do help them out if they're struggling with that. You can actually get a weekly scorecard, so it actually would email you a weekly scorecard telling you all of your energy information that happened for that week on your specific buildings. You can get that email to you, or when you log in where your reports are, you get that report as well. Oh, and then one last thing. We've built this in. This is fairly new. We do have sort of what we call our benchmarking tool, which is the performance tracking. So for instance, if you did want to prove that an energy efficiency measure worked, you can actually just click on any date that you would want. For instance, if you were going to do a retrofit, you could click on that calendar date, type in what you're doing, the type of retrofit you're doing. You can give some little more detail about it, and then you actually enter your cost and say something about it. You could actually put in, and I don't want to say this is accurate because I'm kind of going through the thing, but basically now you've benchmarked that day on when you did the improvement, and so you can kind of come over here. You can see that we benchmarked October 5th, where we installed the light switches, the plugs, the thermostats in the classrooms, and then when you actually click on the details, it would actually now spit out how you're doing and what that change was to be able, to show you how you're doing. It's giving you an energy cost, showing you the before and the after, and as long as your after is staying under your before graph, you're doing pretty well. It gives you the before up in the pie chart, in the bar graphs as well. And then you can actually bring that out over 8 days, 30 days, 8 days, however you want to build that out to show what that energy savings is. and you could do it per circuit if you wanted to. So for instance, how was each circuit affected by that improvement? So for instance, if you wanted to, you know, they always say incandescent bulbs make running times on air conditioning run a lot more. Well, here now we could actually prove out, you know, what the cost, you know, when you put in the LED lights in that classroom, how it affected that specific circuit over 30 days. So there's different ways that we can, again, just within the GreenNet platform, benchmark and utilize data for energy savings.